idea for today is first to speak a bit about Liquid in general, the governance model, how the network works, its relationship with Bitcoin, both from the source code and from the operational side. Uh, Explain a bit about the peg, how the Bitcoin that's circulating through Liquid is actually held in a one-to-one in a Bitcoin wallet. Then we're gonna do some real life demo. Everybody issuing their own assets and preparing for really simple exercises using Liquid Testnet. And then we're gonna talk about a bit more about uh, development tools that are available to develop on Liquid. The old method which is GDK, and the newer ones, which is much simpler, which is LWK. So let's start a bit with the how Liquid works at uh, the governance level. Before we go into that, a bit about Blockstream as a company. The relationship between Blockstream and Liquid is not always known, or the idea is, or the impression in general is that Blockstream controls Liquid, and that's not the case, right? Blockstream is the technical provider for the Liquid Federation, but Blockstream does not have access to Liquid itself. We provide the software, we provide the hardware, but every one of the operators of the functionaries, they have their own access to the functionary, and we don't. That's going to be important later when we describe things a bit better. A bit about Blockstream. Aside from Liquid, we also work on Bitcoin Core. We have maintainers that work on Bitcoin Core, and we develop our own Lightning implementation in Core Lightning. And there's a lot of things that we work on relating to the Bitcoin ecosystem. We have our own from the hardware side. We have our own ASIC that hopefully will be out soon. Because how soon is not clear yet. The finance side, which is a lot of products that are coming out also this year about the Blockstream becoming more like a financial company. The asset management side and with Green as a wallet, and the HSM that we use to handle the liquid network. On the use side, something a service that is not very well known about Blockstream is the data feed. The data feed is basically Blockstream collects information about several tickers and several coins and everything, merges them all together in a unified format, and some companies use that information to control their trading. Right? It's more like an enterprise service that is not very well known, but it's something that we do. On the more on the more user level side is Greenlight, which is an implementation of the Lightning protocol in such a way that you don't need to have your own Lightning node, but you still control your keys. So it's a good balance between having to run your own. It's a good way not to have to have a non-custodial wallet while still with the flexibilities of having a custodial one, because you can have it on your phone. The Blockstream Explorer, I guess everybody has used it to look at the transaction both in Bitcoin and Liquid. And a bit of what we are going to be discussing later today. Within the Liquid network, there's a service called Blockstream AMP, which is a way to regulate the transfer of securities, right? Where everybody's has done the KYC, and everybody has done their own validation for AML and everything. And the idea that behind AMP is that it's not embedded into the network. It's a service that runs on top. So you don't force the network into complying with anything. If someone needs to do things related to compliance, they can be done in a layer on top of that. And simplicity, which is a new scripting protocol that we are creating for Liquid and hopefully for Bitcoin eventually. The idea is to make something much more expressive than that Bitcoin scripting without getting into the mess of the EVMs. Right. So the most important thing about simplicity is that every contract is formally verifiable, which means that you always know how many resources it's going to use, and you always know that what the exit points are going to be. So you can always control the cost CPU wise for simplicity contract. How was the Liquid Network born? It all came from a white paper back from 2014, not too long after Bitcoin. Some of the names you might recognize. Adam is one of the designers of the white paper of the Liquid Network, and some other very well known names within the ecosystem. The idea for Liquid came from extensions that Adam had thought for Bitcoin, like the confidential transactions, which we're going to talk about later, and the idea of using a peg network to Bitcoin in a way that that basically offloads some of the traffic from Bitcoin in order to do separate things that it doesn't make sense to pollute the Bitcoin network with. Bitcoin and Elements. The Liquid network runs on Elements, right? Some of you have downloaded it already. They are running it. Some will do it later today. But Elements is basically Bitcoin Core with some extensions. Okay, it's so close in that you can use Elements to sync a Bitcoin node. Right, it works perfectly fine up until the Taproot activation, because Taproot was designed in Liquid before being ported to Bitcoin. Right, it was developed first in Liquid, which means, and there are a few slight differences, like the exact opcode. So the exact opcode is different, which means that when you try to synchronize the Bitcoin chain with Elements, it changes. So the minute you have your first Taproot transaction, it doesn't work anymore. But you can basically synchronize up until November 2021, and it works. That's how close they are. We always say that it's between 80 and 90% of the code from Elements is actually coming from Bitcoin Core. Reality is we don't know exactly which literal number it is, but it's basically it's the same code with some extensions. When I mean it serves as a sandbox for new Bitcoin technologies, that's exactly what I mean. SegWit was designed or analyzed first within Elements. Taproot too. So the simplicity is being done in Liquid first, and the idea is to port it to Bitcoin eventually. So yeah. So the idea for Liquid is also to help the development within Bitcoin, not just to be isolated, right? Elements is constantly being updated with the code from Bitcoin Core, and then the new things that are developed on Liquid eventually, they are developed with the idea in mind that they're going to be ported to Bitcoin eventually. One thing about Elements is that it also has enabled some of the opcodes that were disabled in Bitcoin, like opCSV. Continuing on that, Elements is the base layer, is the program that runs. In Bitcoin, you have Bitcoin Core, which is one of the implementations, but you could use others to synchronize. And even with that own implementation, you have different chains. Elements can run multiple chains. The classic one is Liquid is the main implementation, but there could be other chains, even private chains that run on Elements with some of the limitations or the characteristics of Liquid, but running within private environments. But yeah, that the idea is that uh, Elements has the ability to be run within private chains, for instance, within banks, associations, and there are instances of Elements running that are not public, right? That are used for intra companies or inter companies that are not for public usage. A bit about the trade-offs. There's a constant discussion about why a layer 2. What do you get out of it? Uh, in order for you to get some of the benefits of a layer 2, you also need to understand that everything is not going to be just as permissionless or just as perfect as it is within Bitcoin, right? And if you're not okay, if those trade-offs are not good for you, then don't use a layer 2 and everything's fine. But the important thing is that when you move into a layer 2, even Liquid, Lightning, or whatever may come up in the future, there's always going to be some sort of trade-off between uh, you lose something from Bitcoin characteristics in order to get something out of the L2. In for instance, in Liquid, you still you have the benefit of the 1-minute blocks, which we are going to speak a bit more later. You have the benefit of the 1-minute block. You have the confidential transactions, but you lose the ability to go back and forth between one chain and the other. You can always do swaps, but you're always within a different realm of transactions. Some people, when we are discussing Liquid, they see Liquid and Lightning as competitive. And from our perspective, they are more complementary than competitive, right? We have people from Chan 3 here, Aqua, and basically they are leveraging Liquid to make Lightning easier, right? So it's not that Liquid is going to replace Lightning, because it's not, but there are things within Liquid that can't be done in Lightning, or maybe shouldn't be done in Lightning. So the idea is that Liquid, Lightning, or whatever other tool that tries to prioritize or to make it easier on to do certain types of transactions, we don't see it as a competition. They try to basically fill different serve as a solution for potentially different problems. Obviously, there is some sort of overlap with some of the characteristics, but it's more complementary than anything else. So this is where we get a bit more into Elements, into the characteristics of Elements. One of the main characteristics is issued assets. And we are going to go more in depth into this, but this is just the introduction. One of the main characteristics of Elements, and Liquid in itself for being a network that is based on Elements, is that asset issuance is native, right? You can issue your own asset within the network, and you don't need any smart contract or any kind of programming tool or anything in order to use that asset within Liquid. So the network handles all the protocols and all the transactions, and every transaction and every wallet that has support for one asset can have support for any asset natively. This is very important for the financial side, and also for securities, because it means that you don't have to audit every smart contract every time, which is one of the the biggest pain points in EVM chains, where you have to audit everything all the time, and even with those audits, things get stolen. Right? This is handled at the chain level, so there's no extra. Right? You issue your asset and it's working. Also, given that you get all the security from Bitcoin, you have multi-sig also embedded in the chain. So basically, you can handle any asset with a multi-sig without any extra tools. Okay. This is for me the most important thing about Liquid: confidential transactions. What it means is that when I send someone a transaction, all you can see is the UTXOs, like in Bitcoin, the source, the destinations, but that's it. You both the asset type and the amount are hidden. So if I swap 10 Bitcoin for USDT, or if I pay a friend for the coffee, from the outside, the transaction looks exactly the same. That that's very good for privacy, and it's also very good for trading, because nobody can front run your transaction. Nobody can actually know the balance that you have in that address, right? So a lot of things are harder to track by design because of confidential transactions. So when we were talking earlier about the trade-offs about using L2s, this is one of the biggest things that you can get by using Liquid as an L2. A bit more into how Liquid works. This basically tries to represent the pegging and the peg out process. Let's say that you wanna uh, use LBTC, which is the liquid representation of Bitcoin. Basically, what you do is you get a pegging address. You send you send whatever coins you want to that address, and after 100 blocks, you can claim that Bitcoin from within Liquid, and you can use it basically with the same RPC, because the elements RPC is practically the same as Bitcoin. So you can use it with confidential transactions, with 1 minute blocks, but using almost exactly the same protocol as you do in Bitcoin. The peg out process is a bit more complicated due to security reasons. So only the Liquid Federation members can do peg outs. We can discuss more in depth about it later in person, about why that is a reason, but it's mostly due to security concerns. Thinking about a potential bug that could happen in the future that we don't even know about it, having the peg out process limited, it's a way to protect the network from unknown unknowns. Okay. This is a bit more detailed information into uh, how the pegging process works. You can see that someone sends a transaction, waits 102 blocks, and then it claims from the other side. One thing about Liquid itself is that there are no reorgs, right? That means that once a block it has two confirmations, it can never be rewritten, right? Only the topmost block can, in theory, be replaced by another block with the same height. Even though in theory this is possible, in over 3 million blocks that we have on Liquid today, it has never happened. But in theory, it's possible. So that's why we say that Liquid has a 2-minute finality. You generate the block, and once you have a block on top of that, you know that the transaction is never going to be replaced. So how are the blocks produced in the Liquid network? Liquid network is not proof of work. It's not proof of stake. Is a federation. It's an 11 out of 15 signatures. So in order for a block to be valid, it needs to have 11 out of 15 signatures, right? If you look in the chain, you can actually find the Bitcoin script that represents the liquid network is 11 out of 15. And yet you can look at the 15 pub keys. What happens is that there's basically a round robin. Every minute, one of the 15 functions proposes a block. The rest of the functions validate it, sign it, and send the signatures back. And then everybody combines the signatures and add the block to the chain. So every minute, one functionary proposes a block and the rest accepts it. The way that it works is that if one functionary is down, that round is lost, right? That minute you don't have a block, and the next minute the next functionary picks it up and keeps the ball rolling. So the idea is that the redundancy is actually part of the 11 out of 15. If one functionary is down, yeah, it's down. Obviously, if it's going to be a long-term thing, we contact the operators. We try to get everything back online. Or if it's going to take way too long, we can spun up a replacement. But in the day-to-day normal operations, if one is down, and it's fine. Right? It's part of the resiliency of the network. The way to handle that. Who's who within the liquid network? Anybody can create transactions. The network is completely public, right? Function operator is the entity that runs one of the 15 signatories, the functionaries. The federation members are like a superset of those 15 that are the people who make the companies that make decisions with regard to the network. We're going to talk about a bit later about what kind of decisions we're talking about. Anybody who node operator is anybody who runs an Elements node. And wallet user is normally the person that has like a Ring wallet on their phone or Aqua. So let's talk a bit about this matrix here. Wallet users can basically create transactions. That's what you want to do. They can't verify transactions because they are normally thin clients. They basically connect to a block explorer in order to get their own transactions, but they don't have a full chain. They can peg in Bitcoin and they can issue assets because all of those are normal transactions. They can't peg out because of what I mentioned earlier, and obviously they can generate blocks because they don't run one of the 15 bug keys. A node operator basically can do exactly the same thing, but they are also validating the chain all the time. Right? Every time an Elements node gets a new block, it's going to validate all the transactions. A federation member is almost the same as any regular node operator, with the exception that they can peg out. Right? They can send money back into Bitcoin. For normal users, this doesn't make any difference because there are several companies that implement atomic trustless swaps, which means that you don't need to do a real peg out to get your Bitcoin back, right? You can do a swap with Balls or any other company. Just do it, and it's actually faster because normally it's done via Lightning, so you get your money back almost immediately, right? And the only extra thing that the functionary operators can do is to generate the blocks every minute. That's it. Continuing with the who's who within the Liquid network. As I mentioned, the functional operators are the entities that run each one of the 15 potential signatures, both for signing blocks and for controlling the wallet on the Bitcoin side. They have some specialized versions of hardware that's called an HSM that handles the keys. one of the misplaced criticisms on Liquid is that say, yeah, if one of the operators wants to do something, they can just get the key and do whatever. The keys are held within the HSM. So even if someone has physical access to the function, that doesn't mean that they have physical access to the keys, right? So it's not, I don't like to say that it's impossible because there are a lot of things that I don't know, but it's certainly not easy or not normally doable have a way to access the keys directly. So even especially without anybody noticing. So even if if some of the operators became malicious enough, they'd still not be able to access the keys within the HSM. Right. Liquid members are basically the entities that decide what's going to happen with the network. We're going to talk about a bit more later, as I mentioned. But one of the changes that was done lately in the network to reduce the way that fees are calculated are things that are done through proposals from the liquid members. And also they have the ability to do real payouts. Full nodes, any one of you that's running elements and synchronizing the chain that is validating it all the time. And as I mentioned before, Blockstream. Blockstream is as a technical provider for the federation. Uh, Once again, we make our lives a living hell by trying to separate what Blockstream does as a provider and basically not having access to the functions, right? It would be a lot easier for us to have full access to the functions, control everything, update everything without needing the operators, and everything would be a lot simpler, but it would not be correct. And we want to do things the right way. So Blockstream provides the software and part of the hardware, and the operators run their nodes, and sometimes we don't even know where they are, right? That's we try to do things the right way, whether somebody's looking or not, right? So the idea with Liquid is it's not easy to handle things that way, but it's what we consider the right way to do it. A bit about how the Liquid Federation works. The Liquid Federation has three governance boards. The membership board, which decides who can join the Liquid Federation, who's going to be able to participate in the future. The oversight board, that is more like an internal controlling board. They decide how all the decisions are going to be made in the future. And the technology board, with what I mentioned earlier about changing the way that fees are calculated, that's a proposal that came from the technology board. Basically, the technology board is the one that works more closely with Blockstream about the technical features of the network. Uh, Elements Improvement Proposal, ELIPS. As I was mentioning earlier, this is something that started not too long ago, but it's given us very nice results. The idea is that every change that is done to the Liquid network, to the protocol, gets proposed as an ELIP, the same way that BIPs work in Bitcoin. So if it works in Bitcoin, we try to adapt it because it's very likely going to work for us. So the idea is, we call it discount CT. There was an issue with, not an issue, but a situation in Liquid where, given the type of transactions, the confidential transactions were roughly 10 times bigger than the non-confidential transactions, which means that we were basically punishing people for being confidential, right? It was not on purpose. It was just the size of the transaction that is bigger. but there was a, f- mm, a financial advantage to use non-confidential transactions, right? So one of the proposals that were basically deployed in the last few months is to change the way that the fees are calculated with confidential transactions, which means that there is absolutely no benefit financially wise uh, to use explicit transactions. You use the same transaction, confidential or non-confidential, and it's going to cost you exactly the same, right? So the idea behind Ellipse is that's one example, but the idea is to control and to show the progress of potential improvements to the network and the reasons and what they're going to look like. So this basically every if you were doing let's do you're doing a payment in USDT on Liquid, and the base fee that you were going to pay for the transaction was roughly 250 sats, which is not a big deal, but it's mm, not nothing. And after we enabled this slip, it went to you could even have 25 sats per transaction. So when you're thinking about uh, doing swaps for Lightning payments, right? Instead of running your own Lightning node, you could run a swap. It's a really significant difference. A couple of different places where you can get information about Liquid. The blog, mostly read-only YouTube videos with docs like this from other places in the world. Uh, Documentation, docs.liquid.net, the elementsproject.org, which is more like you get the tutorial and you get other type of more technical resources for you to start running your nodes and things like that, or the GitHub page where the elements code is developed. That's it for the introduction. The idea now is to get everybody to start updating your installing an elements node for the demo that's going to come later. I have my laptop running an elements node here, so the idea is instead of using internet and everybody overloading the network, I'm going to give you my IP address so you can connect to my node and get the chain as fast as possible from here. Who has their elements node installed already, or you don't count? So if you want to go to this address, github.com elementsproject/elements, and download the right version for you guys. And that's yeah, yeah. That answer is easy. It's literally the same number of blocks that miners get before they can actually spend their mining fees. So it's basically they said if it's good enough for miners, it's good enough for us, and no less. I guess that's the reason for that specific number. It's the same. It's choosing the same number that Bitcoin chooses for the mining fees. Okay, perfect. In the second question, and the second, yes, yes, the second part, yeah. Second question is why 1 minute and not less? Let's say block confirmation time. Why 1 minute and not less? Because when we started the network, 1 minute was good enough. Now changing the time from 1 minute to anything less than that is break a lot of assumptions on the network, and that's not something we don't want to do. But when I was explaining earlier about running private chains or in the future we're planning on maybe running different public chains based on elements, but they are not exactly liquid. And the plan for those could be to have shorter block times. I mean, we have internal networks that even run at 3-second blocks.
Yeah.
Okay. So it's not a 10 at this moment. That in the moment when the network was created, was a number that made sense. But there's no technical thing that says no blocks need to be 1 minute. It's just yeah, makes sense. That's it.
Sorry, but currently, do you receive the money? You still have to wait that a minute to see.
You can see it from the mempool, just like in Bitcoin.
Okay. So yes, can see it instantly. But in the long term, the idea is to have a layer 2 for that kind of use cases.
For the idea is to potentially have different networks for different optimizations. One of those could be having faster blocks.
Okay, each one like attached to liquid.
Once you implement the swaps, it's you swap from one network to the other and you're good.
Also, if you're trying to get instant confirmation, it's technically liking race on liquid. Zero.
Yeah, exactly what I was going to mention. So we are working with some operators, mainly balls, where uh, there's a process monitoring the mempool of the functionaries, which means that they can basically, without too much doubt, accept zero conf and basically do a swap based on zero conf because they know that the functionaries have already seen the transactions. And given that elements does not have enabled, and we don't plan to enable full RBF, so that means that once the functionaries have seen the transactions, there's nowhere to replace it.
Okay.
So accepting zero conf is much less problematic than in Bitcoin. Yeah, if you have the old RBF enabled, sure, you can do it, but nobody's gonna accept a zero conf on an RBF flag transaction. Okay. Yeah.
All right, mine is a little bit follow.
Yes.
So why is the finality secure? Is reword.
Yes.
Basically, can't the Federation is basically choose to collude and change that?
So it's not a matter of the federation; it's a matter of the HSM. So in order for you to collude and change that, you have to have access to the HSM to change that. Which means if you have access to the HSM, and in order to do that, it's the same level of complication as extracting the keys from the HSM.
So basically, the Federation can't.
They can't. They can't. What I was mentioning earlier about the difficulty of accessing the HSM, changing that rule means changing the HSM. So the thing is, the HSM will never sign a block below the last block that it signed. Right? And since the keys are inside the HSM, that's it. So let's say that we produce block 10, and I try to produce block 10 again. It's gonna work because it's a normal situation. It has never happened, but it's technically possible because let's say that you sign a block, then you lose a round, right? Because not enough people were available, whatever. It makes sense for you to try to sign the same block again. But no HSM is gonna sign block 9 if it's already signed block 10.
Okay. So thank you on that one. But to understand a little bit more on the HSM,
Yeah.
specifically, you said that Blockstream is not specifically they're not an operator, so
Yes.
you're not run the HSMs.
Mhm.
So what was the verification process that went behind the setup to up those HSMs so that we know that it's even secure the fact that they're
So the source code for the functionality is open source, it's public. The source code for the functionalities is not. So there's been some audits in the past about the HSM, but not lately, and not sure what more I can tell you.
So you're saying there's no way to buy that these
For normal people, no. The federation members, yes, they can do it and they do it, but from normal people, no. But when you have federation members like Bitfinex and Bolts and others, Chan 3, they know what they are doing. They know that things are the way they should be. Yes.
How is decided? I mean, what's the mechanism? In Bitcoin, we have a market for fees, and in Liquid,
Okay. So in Liquid, fees are less important because basically Liquid is a tool that they use to make money on top. But the fees in themselves are not the target of the Liquid network. Okay. So how do I say this? I was talking earlier about AMP, about the process to validate trading of securities. Well, some company issues the securities and they make money by their securities, right? So they don't care about the Liquid fees. The main reason for the fees on Liquid are to pay for the sweeping of the transactions in the Bitcoin wallet, which is something I didn't explain because it's a bit too much for now, but we can talk about it later. And it is to do that and to avoid spam on the network, right? But nobody's gonna make money off of the fees on Liquid, right? So the idea is to do everything to keep the fees high enough that there is no spam, but low enough that it's basically cheap for everybody.
I see.
Okay.
What happens if somebody runs a spam attack and fee rate should be increased, right, to protect?
It's the same protocol as Bitcoin. It's basically so if somebody runs a spam, uh, tries to run a spam attack, the fee rate is gonna spike, and then it's gonna normalize. And depending on the type of transaction, we could analyze what could happen. But the idea is that the fee the fee rate is we want everything to we do everything we can to keep the fee rate low so that everything's more predictable.
I see. And also related question, who collects the fees?
So the fees are collected in a common wallet among all the functionaries. Blockstream, that money does not go to Blockstream. Blockstream, as a technical provider, does the administration of that wallet. But and I can actually send you the address so you can follow exactly the number of transactions. There's roughly three and a half Bitcoin in fees collected over time. And this collected over 12, but the rest was spent basically sweeping the transactions on the Bitcoin side, right? Because all the UTXOs that go into the Federation wallet, into the Liquid Network wallet, are constantly being swept again onto themselves in order to make sure that they never expire. Because if they expire, they can be used by the emergency keys, which is something we don't want. So Liquid Network is constantly paying for transactions on the Bitcoin side in order to keep those UTXOs from ever expiring. So the most important use of the fees collected on Liquid is to pay for those transactions on the Bitcoin side.
I see.
So maybe explain the UTXO suite
Okay, yeah.
and the time lock there. And basically, it's another contingency plan.
Yeah.
Security layer.
So
That's those fees are. Like I said, you can go to like liquid.network, right, which is ran by mempool, space,
as with liquid blockchain, and they have the publicly audited fee wall. Go there and see the federation's wall. So there's many ways you can kind of.
What I was mentioning is about contingency. The blockchain production is 11 out of 15. The block signing production is 11 out of 15. The wallet that handles off the pegged Bitcoin is also 11 out of 15, another set of 15, but it's still 11 out of 15, but with a small caveat. It's 11 out of 15 plus 2 out of 3 after 4,032 blocks, right? What it means is if there were to be a catastrophic event where the network can't produce blocks anymore and everything's basically dead, there is a way to recover all those almost 3,800 Bitcoin that are on the network right now, because after 4 weeks, those UTXOs can be claimed and given back to people, to the owners. Okay, so that's good for emergencies, which we never want to happen, but we want to be prepared in case it does. But it also means that constantly we have to be sweeping those UTXOs on the Bitcoin side, no matter the fee rate, because we never want to get to the point where they are spendable by the emergency keys.